Okay, Sairam. So let's again start with it. Uh, Now we have defined number of physical quantities like wavelength, period, frequency, velocity, phase, right? Wave number, propagation constant. We have defined all these physical quantities. Even phase difference, all these terms we have seen it. Tell me which physical quantity represents color. Which physical quantity represents color? We have been talking about the red rose, green stem, red color, yellow color, green color. So which physical quantity represents the color? Wavelength? Frequency? Now it's very easy to answer wavelength or the frequency. You need to explain why. Why do you think that frequency represents the color, wavelength represents the color? Yes, both can also represent. Then color is represented by both frequency, wavelength. Anyone? Okay, have you heard about refraction of light? Can you tell me what do you mean by refraction of light? Bending. Bending is refraction. Scattering. If your sir says bending, जाने दो. Scattering. Scattering. छोड़ दो और कुछ नया. Is this the way you are going to learn? Bending. So at the old age, an old man bends. So you will say that at the age of 80 he got refracted. So when the medium changes, it is changing the path either towards the normal or away from the normal, then you call it as refraction. In a refraction of light, does wavelength change? So anybody who can tell me what is the refractive index? Anybody who can tell me refractive index? Right? Somebody is saying rightly. Correct. So you are writing here the refractive index. It is denoted by eta is equal to speed of light in vacuum upon velocity of light in a medium. What is speed? Frequency into wavelength, right? So can I write down speed of light as frequency in vacuum multiplied by wavelength in a vacuum divided by frequency in a medium divided by lambda in a medium? Right? So in this case, the frequency do not change. The frequency is remaining constant. And as the frequency is remaining constant, frequency of the violet light in a air medium will be equal to frequency in a medium or a vacuum is equal to F. You will be having refractive index lambda in a vacuum divided by lambda in a medium. Frequencies are? Then refractive index will be always 1. Yes, frequencies are equal, but wavelengths are not equal. That's what I'm trying to tell you. If I consider frequency equal and lambda also equal, then refractive index will be 1. It cannot be greater than 1. We are aware of the fact that speed of light in a vacuum is greater than speed of light in a medium. Am I right? So the ratio should be greater than 1. Now frequency do not change, but wavelength is changing. Now let us try to understand one of the important consequences of that. Suppose in a swimming tank, you are having a blue color light inside the water. Will it appear to you green outside the water? Because the light is traveling from water to the air, will it appear to you as green, red, yellow, or will it appear to you blue only? Are you getting this point clearly? Similarly, if you are changing some red light inside the water and you are looking outside the water, will it be remaining red or it will be changing the wavelength to yellow color, blue color, any other color? It will appear to you red. So, frequency do not change in refraction. Only wavelength changes. Color do not change on account of change of medium, and therefore color is represented by frequency. Technically speaking, speed of light in air for any color is going to remain constant. So if the wavelength of the color changes, frequency also changes. But in case of refraction, the frequency doesn't change, color doesn't change, and that is why we say color is represented by frequency only. Getting this point clearly? This was the one important point. Second important point is called as persistence of vision. Are you aware of persistence of vision? On one side of the paper you draw a cage, on another side of the paper you draw a parrot, and you start rotating the paper with a great frequency. After some time you feel that the parrot is in the cage. Have you performed this demonstration? Done? Why it happens? Why it happens? Anyone? Now what happens? Our brain senses all the images. If you are having the image coming to your brain in less than 1/10th of a second, the images are getting overlapped. Those images are not sensed by the brain. Eyes are used to see the object, but the perception of the object is made by the brain. In this particular case, the light from the object is getting converted into the electrical signals, and these electrical signals, when they go in a region where optics are part, optical region of the brain, then we are able to sense the image. Are you getting me clearly? Getting this part? Now, suppose we are looking at the pictures that are coming for 1/10th of a second less, then the pictures will be missed by us. We will not be able to sense it. And that is the reason overlapping pictures give you the impression that parrot was inside the cage. When you stop the page and turn around, you are able to see cage differently, parrot differently. This is called persistence of the vision, which is 1/10th of a second. You can check it out. Abhi forward hota hai, matlab I know that part. You can see the video with a twice speed. On a YouTube, you can see the video with a twice speed. Now, if you are looking at the video with a twice speed, if you make it 10 times, pictures will not be sensed by the brain. If you make it 100 times, number of pictures will be missed out. That is because of persistence of the vision, which is 1/10th of a second. Question arises that suppose there are two chairs on the desk, on the stage here. So I was talking about what we call it as resolving limit. This is a very important term which we are calling it as a resolving limit. there is a certain limit up to which we can see the two objects close to each other from a certain distance. Beyond that distance, the two objects cannot be seen distinctly, they will appear to you as one. For example, if you are keeping two chairs at a distance of 50 meters apart from each other on the earth, you will be distinctly able to see them. एक चेयर ऐसे दिखेगा 50 मीटर दूर कहीं और दूसरा चेयर दिखेगा. Will you be able to see the two chairs distinctly which are 50 meters apart on the earth? Obviously you can see it because you are yourself on the earth. But if you keep the two chairs on the surface of the moon 50 meters apart, you will not be able to see the two chairs, it will appear to you as one. Because resolving limit of our eye is less than 1 minute. 1 minute? 1 minute कौन सा? 1 minute कौन सा? घड़ी का? कौन सा 1 minute कौन सा बोल रहा हूं? Which 1 minute I am talking of? Angle. I am talking of angle 1 minute, not of time 1 minute. Able to get it? So if you are having the resolving limit of your eye only 1 minute, then you should understand that maximum up to the angle of 1 minute, you can see the two objects distinctly. Beyond that, यानी 1 minute से कम अगर आप कर दोगे, you will find that the two objects cannot be seen distinctly. Okay? Now how we can say that? This can be shown here in this manner. This is object 1. This is object 2. The distance between the two objects is taken as equal to d. This is representing the perpendicular distance d. Here you will be keeping your eye and you will be joining these rays here. Then this angle is taken as theta, that will be defined as opposite distance, opposite side upon capital D. This theta is called resolving limit. Of I. Resolving limit, and resolving limit of I is 1 minute. एक मिनट का एंगल होना चाहिए. The angle should be less than 1 minute. You will not be able to resolve. If the angle is greater than 1 minute, you will be able to resolve it completely. Now you should be aware that 1 degree is equal to 60 minutes. So you will be having 1 minute will be equal to 1 multiplied by 1 divided by 60th of degree. That is 1 by 60th of a degree. Now you are having that particular angle measuring instrument with you, that is D, protracted. You measure 1 degree angle and divide that 1 degree angle into 60 equal parts. Then one part of it is the resolving limit of an eye. Are you getting what I'm saying? You have a D with you? Just look how small 1 degree angle is there. And divide that 1 degree angle into 60 equal parts. 60 equal parts. Can you see every small part of it? That is the resolving limit of an eye. Now it's very clear. Suppose you are having the distance between these two. D is taken as equal to 1 meter. Distance between the two objects. Then what will be the value of capital D if resolving limit theta is taken as 1 by 60 degree, or it will be taken as 1 minute. So you can calculate this by relation. Capital D will be equal to small d upon theta. Now this theta is to be expressed in radian. So radian के लिए आपको लिखना पड़ेगा pi radian is corresponding to 180 degree. So 1 by 60 degree will be corresponding to how much? So you will be having 1 by 60 multiplied by pi divided by 180. So you will be writing this to be equal to D is 1 meter divided by pi upon 60 into 180. So you will be having this as 60 into 180 divided by pi. So approximately you can calculate. I would like you to work some more time, but numerical ability is to be built up. So that is the requirement. So anybody who can get the exact answer of this part. Right? So that is how we are able to calculate the part. तो इसको एक चीज यहाँ पर है जो important है. What is the value of pi? Known to everyone. 3.142, that is equal to 22 by 7, right? But what is the value of 1 upon pi? So do you feel that I don't know this value? 0.3 something. This is our problem for the NEET examination. Why don't we memorize this value of 1 upon pi? Because it is going to come at number of places. By doing 22 by 7 or 7 by 22, division by 22 is not going to be that easy for you. Instead of that, if the value is known to you, I think it is 0.3162. You can proceed here by using this particular part, 7 upon 22. So 22 3s are 66, 40 is remaining, 1s are, that is giving me 22. It will be having the remainder as equal to how much? 40 था 18 हो गया तो 22 6 132 आएगा, 3.613162 आता है. Now this value is to be memorized. The moment you are able to see 1 upon pi, you should be able to multiply it by 0.3162. 3184 है कितना है? Calculate करके देखो, मेरे को exactly याद नहीं आ रहा है, क्योंकि I have told you in the morning I have stopped taking the classes since 2 years. It's only because of Swamiji I am here. That I can tell you. I have taught for 28 years. So huge period of my life has been devoted to that. I am working in the field of education, but not to the student education, but to the teacher education and creating the content. That is the area I am working now. कितना आ रहा है? 0.3184 आ रहा है या कितना आ रहा है? 3184 आ रहा है शायद. 312 3182. एक बार डिवाइड करके उसको याद करना है सबको. 3181 या 82, that was I was remembering it. ये मैं 62 कहां से आ रहा है वो भी बता देता हूं, so that you can remember it. Just remember that. Now what is under root of 10? Under root of 10. पूरा आंसर बताओ. ये कहां से आया था 6 में वो बता रहा हूं आपको. अंडर रूट ऑफ 10, this is actually 3.162. And what is 1 upon under root of 10? This is the magic that you will be able to see, 0.3162. आप करके देखिए, आपको पता चलेगा. This is true. इसलिए मुझे याद है वो 3162 मैंने जो लिखा था, बिकॉज ऑफ दिस √10 आई हैव रिटन इट, बट थोड़ा सा याद आ रहा था कि सर इट इज नॉट 6, इट इज 8. So it is 0.3182 for 1 upon pi. So just remember the values, because the value remembering is extremely important. देखिए, if you want to calculate it, you will be giving some time. If it is already memorized by you, it will be saving some time. So time ka race hai. You are racing with the time in competitive exam, so you should take care of such numbers there. So that is why this concept is there, that what is limit of resolution or resolving limit of the eye is actually 1 minute. Less than 1 minute, you will not be able to resolve the two objects distinctly. That is the meaning of it. Okay? Now give there a heading that is called principle of reversibility. Now this is the most important principle in optics. Once you are able to master it, you will find that optics becomes easier for you. You have learned something about reflection of light? Am I right or not? So suppose I am having here a plane mirror, and I am keeping the pointed object at this point. Can you draw the ray diagram for the image? How will you draw the ray diagram? Plane mirror, not a focus. The focal length will be infinity here. प्लेन मिरर की बात कर रहा हूं मैं. हाँ, image will be formed at the same distance, but can you draw the ray diagram? You are having a pointed object placed in front of a mirror. I want you to show the image formation. And that is why I have asked you to bring the compost box with you. Because without that you will not be able to draw. We can draw it, but perfection will not be there. कैसे सोचेंगे इसके बारे में? From where the light should come? From the object. So how many ways you can show the light here? You can show the first ray of light to be traveling along a straight line here. The angle of incidence being equal to 0, the angle of reflection will be 0, the ray will be passing back. Am I right or wrong? But this will not help us to point where I should mark it, the image. Obviously, this is telling you that the ray is getting reflected from here, so there will be some point on this line from which the ray has come back. Then we will take some different point. I'll consider the ray to be traveling along this direction. Will be incident here. I will be drawing the normal here. With the same angle of incidence, I will be showing the angle of reflection like this. Angle I and angle R are equal here. And for me, as the light is entering my eye here, I will be having the eye here, looking at the eye from this side. The light appears to me to be coming along a straight line from this point here. Light appears to me to be coming from this point of intersection here. Am I right or not? Getting it clearly? I will be able to say that this distance is equal to this distance, so the image will be formed at this particular point. Are you getting this? Is it necessary that I have drawn a ray from the object in a downward direction? I can draw another ray in this manner. Again, at the point of incidence, this will be the angle of incidence. With the same angle, you will be able to show the ray reflected along this line. So the ray will appear to you to be coming from this particular point only. So image will be formed here. Are you understanding how the ray diagram has been drawn? Now you will say that why only 2 rays? Can we draw with more rays? Yes, I can draw with more rays. There is no issue about it. I can show the ray to be incident along this direction. Again, at this point, I will be having angle of incidence. With the same angle of incidence, I will be showing the angle of reflection like this. If you stretch the ray in a backward direction, it will come to the same point. Am I right or wrong? If I want to show it here, I can show it like this. The ray will be moving back along this direction, and if you stretch it backward, it will be coming to the same point there. Getting this part? Getting it? Now suppose my object is present behind the mirror, then where will be the image formed? Behind the mirror. How are you going to approach that? There is nothing in front of the mirror, so no object will be able to see. No, that is the problem, because actually you are calling this image real or virtual. So a real object is producing the virtual image. So if there is a virtual object present here, then it will produce a real image. Now we know that object is always real. But if I consider a virtual object that is placed behind the mirror, then I will be able to get the position of object, which is the image of the virtual object. I'll put it like this. Now, you will find here that the ray of light which was moving outward, if it is directed towards the virtual object, what would happen? This is the ray of light directed towards the virtual object. So the light is coming from this side, directed towards the virtual object. The ray of light will suffer the reflection, yes or no? It will suffer reflection. Obeying the laws of reflection, you will be able to draw this horizontal line, which is a normal here. This is angle of incidence. With the same angle of reflection, you will be able to see the ray of light traveling like this. Am I right? Similarly, this ray was moving outward. If I draw this ray at this position, directed towards this virtual object, directed towards the virtual object. This will reflect from the mirror, and you will be able to see that this reflected part will be traveling in this manner. So this is representing to me the real image. Are you able to see that I am retracing the same path by changing the direction? Able to see it? I have drawn both the figures one below the other, so that you can see here this green light is moving away from the mirror. I have taken the same path, taking it towards the mirror, directed towards the virtual object. After reflection, it is meeting at this point. Again, the green ray was traveling away from the mirror, entering the eye. I am now causing the red light to travel along the direction of virtual object and intersect at this point. So ray diagram here and here is telling you the reversal of path. Am I right or wrong? Am I right or wrong? This is called as principle of reversibility. Able to get the principle of reversibility? This is extremely useful in drawing the ray diagram, because principle of reversibility will allow you to understand how the rays are going to be drawn and how the path of the rays will be traced out. You just mentioned there principle of reversibility. If a light ray is reversed, it always traces its path. It always traces its path. Next line. In accordance with principle of reversibility, object in accordance with principle of reversibility, object and image positions are interchangeable. The points corresponding to object and image, are called conjugate points. Can complete the figure. आप फिगर निकाल के देख सकते हो, but that is required. Object and image points can be interchanged. That is the meaning of that. Now, do you know the law of reflection? You know the law of reflection? What is the first law? Angle of incidence is equal to angle of reflection. Do you know how this has been derived? We know the law, everyone knows the law, but nobody has ever bothered about how this was derived. Do you know the law of refraction? Law of refraction. refractive index of the medium with respect to the vacuum is the ratio of sine of angle of incidence to the sine of angle of refraction. Sin I upon sin R is taken as refractive index. This is the law of refraction. Again, nobody knows how it was derived from. So the basic principle by which it was derived is mathematical in nature and is known as Fermat's principle. So just mention the principle. It is for your reference that how these laws of reflection and refraction had been derived from. So actually the name of the scientist is Fermat, F-E-R-M-A-T. Fermat nahi bolte usko, Fermat. In chemistry you are having some series. Spectrum, Lyman, Balmer, Paschen, bracket. I was aware you are going to say P-fund. It is never P-fund. It's only called fund. P is silent there. Probably in chemistry and physics, another important word you are coming across. D-E-B-R-O-G-L-I-E. It is never de Broglie. De Broglie. So you can check it on Google, whatever I have said is correct. So you should use that terms only. De Broglie. This is not the way. It's De Broglie. So that is the reason I thought I should be able to tell you Fermat principle they call it. F-E-R-M-A-T. A light ray traveling from, what is the Fermat principle? That you just mention it out. A light ray traveling from one fixed point to another fixed point follows a path such that compared to the nearby paths, the time required is optimum. Time required is optimum. Write down the meaning of optimum in a bracket. Either maximum or minimum or constant. Either maximum or minimum or constant. Now you'll say, sir, optimum, maximum, all it is maximum, it is minimum, it is constant. How it is that possible? So it is a mathematical term which we learn in mathematics. How many of you are having mathematics? You all are having it, right? So have you learned about the derivative? In maths, have you learned about derivative? There is a term called as maxima, minima. First order derivative, second order derivative. If second order derivative is positive, then it is a case of minima. If the second order derivative is negative, then it is a case of maxima. In that case, the first order derivative to be equated to 0 to find out the given mathematical condition. So that maxima minima has been applied in a Fermat's principle. So that is why it is containing maximum or minimum or constant. Right, suppose you are having the second order derivative neither positive nor negative, but it is 0. Then in that case, dy by dx is taken as a constant there. So that is the reason why it is containing the meaning of word optimum given here. Write down the last part. Optical path. Optical path. Optical path is defined as distance traveled by light in vacuum, distance traveled by light in a vacuum in the same time in which it travels a given path length in which it travels a given path length in a medium. Are you able to get the meaning? Please read it out and see whether you have got the meaning or not. Suppose you are having D as distance covered by light in a medium. T is representing the time. V is representing velocity of light in a medium. Then can I write down the value of time here is equal to D upon V? D is the distance traveled by the light in a medium. V is the velocity of light in a medium. So time taken by the light to cover a distance D in a medium will be given by T is equal to D upon V. Then optical length. Then optical length is equal to L is the speed of light in a vacuum multiplied by the same time t. So I will be able to write down this relation as C multiplied by D upon V. This is equal to mu times D, where mu is standing for refractive index. Now, are you able to understand what is optical length? The time in which The light travels a certain distance d with speed v in a given medium. In the same time, what will be the corresponding distance traveled by light in a vacuum? That corresponding distance in a vacuum is called optical length. Okay? It's very easy to understand. Suppose I put it down in this manner. The refractive index of glass is 3/2. This is for glass. So refractive index of glass with respect to the vacuum will be taken as equal to velocity of light in a vacuum upon velocity of light in a glass. So velocity of light in a glass will be taken as equal to velocity in a vacuum is 3 into 10 to the power 8 divided by 3/2. So your answer would be 2 into 10 to the power 8 meter per second. Able to get this part? यहाँ तक समझ में आ रहा है? So if I take here 5-second time, so for a time of 5 seconds, what will be the distance covered in the glass? Distance covered in the glass would be velocity of glass multiplied by time. So you will be having this as 2 into 10 to the power 8 multiplied by 5. So you will be having 10 to the power 9 meters. Now in the same time, what will be the distance covered by light in a vacuum? So distance covered by light in a vacuum, optical length, this is known as optical length. That will be taken as equal to speed of light multiplied by time. So 3 into 10 to the power 8 multiplied by 5. So you will be having 1.5 into 10 to the power 9 meter. So optical length is always going to be greater than the length covered by the light in a different medium. Able to get it? ख्याल में आ रहा है? इसी को हमने इस तरह से लिखा हुआ है कि optical length is taken as mu times d. बराबर है? वो फॉर्मूला आखिरी में लिखा था. So refractive index is taken as 3/2 for the glass multiplied by distance covered in a glass, that is 10 to the power 9 meter. इसको भी सॉल्व करेंगे तो सेम ही आंसर आ रहा है या नहीं देख सकते आप? ये दोनों आंसर सेम है. तो ये जो फॉर्मूला दिया है कि रिफ्रैक्टिव इंडेक्स इनटू द डिस्टेंस ट्रैवल्ड बाय द लाइट इन अ गिवन मीडियम, दैट इज डायरेक्टली गिविंग अस द ऑप्टिकल लेंथ. Are you getting me? Ask, no problem. So I'm able to create a background for you for learning of light. Now tomorrow actually the light will begin. We'll start with reflection of light from the plane mirror, move on to the curved mirror. But as I have told you that you should be able to make the list of the formulae today, memorize the content of today, get it prepared, then you will find tomorrow's lecture to be interesting as well as you will be able to think about it. On the other hand, I have given you certain tasks. कल क्या क्या लाना है? Geometrical box, log tables, and you have to come prepared. और क्या बोला था? कौन से 4 चीजें बताई थी स्टार्टिंग में? So have you written the questions today? Are there any additional questions from you, from your brain, added to that list? So how many questions you have handled today? We have handled today rather. Great number. And how many hours you have been listening to me patiently? Six hours? Almost 6 hours, no? So, two Hindi movies. Old days Hindi movies, 3 hours. It's like that only, that entertainment don't make you feel that you are tired, but probably you are tired. I don't know whether it was interesting or boring for you, but I thought I should be able to present something to you differently so that your understanding level of the subject is increasing. Hope you are all enjoying it. Tomorrow I am going to come to know positively how many of you have enjoyed. Because I have already told you I will be asking you the questions tomorrow as soon as you come up. And those students who will be coming late, they will be asked more. Because they are trying to avoid the first partner, that is why they will be coming late. So I am taking care of them. So hope you are enjoying the light. We'll deal it thoroughly and you will find that it is the easier topic. See you. Bye. Sai Ram.